Hello, physics people. This is Chapter 12, Lecture 2, on page 400 in your book. And this lecture is going to be about refraction and Snell's law. So on your notes, we're on page 2, here at the bottom. And just a little bit of vocabulary. An opaque object is when light does not travel through. So some is reflected, some is absorbed. An example would be a normal wall, like a sheetrock wall. Okay, a transparent object, some light passes through and some is reflected. So that'd be true with a window. Refraction is the bending of light when it encounters a new medium. All right, so go ahead and pause the video, and I've got some space down here for you to draw this example of a refracted light beam and have defined these angles. So go ahead and pause the video, and then I'll talk about it after you've drawn all this out. All right, so this line here represents an incident beam. Okay, so that's from the source. Okay, so let's say that all around here is air, and then within this rectangle is water. Okay, so theta 1 is the angle of incidence, and it's the angle between the incident beam and what we call the normal line. Normal is a mathematical word for perpendicular. All right, so the normal line, perpendicular. Some of that light is reflected. So theta 3 would be the angle of reflection. Some of that light passes through the water, okay? And you can see that theta 2 is smaller than theta 1. And that's not always the case. Sometimes it's bigger, but that angle theta 2 between the normal line and the refracted beam, all right? So that's the refracted. That angle is called the angle of refraction. Now, the reason that light is refracted or bent when it encounters a new medium is explained extremely well on page 401 in your book in figure 12.8. So read through that. No reason for me to read that for you, but it has a lot in common with the way sound, the Doppler effect in sound, so read through that explanation, and we will move on. If you'll turn to page 3, we will move on to the math of refraction and Snell's law. All right, Snell's law, okay, you're going to have to memorize this, is N1 times the sine of theta 1 is equal to N2 times the sine of theta 2. The theta 1 and theta 2 are in the previous illustration that you just drew. So N is the index of refraction. So that's going to be different for every medium. So air has one, water has one, anything transparent would have one, different for. Diamonds have one. And the way that you calculate the index of refraction is you take the speed of light in air and divide it by the speed of light in the medium of interest. Now that's in your notes, but of course this is going to always be 3 times 10 to the 8th on top, and then it's always going to be divided by some number that is smaller than 3 times 10 to the 8. Okay, so your index of refraction is going to be 1 or greater. So N is equal to 1.0 for air. So you need to memorize that. All right, let's look at on your own problem 12.4 on page 405. Okay, that problem reads, the index of refraction for water is 1.3. What is the speed of light in water? All right, so we'd have N for water is equal to the speed of light in air over the velocity of light in water. So rearranging and solving for the velocity, it's going to be the speed of light in air divided by the index of refraction in water. So that's 3 times 10 to the 8th divided by 1.3. All right, and that is 2.31 times 10 to the 8. Index of refraction doesn't have units. So you can see light is quite a bit slower in water than in air. And that difference in speed is what causes it to bend. All right, pause if you need to, and let's do 12.5. All right, 12.5 says a light ray travels through air and then encounters diamond with an index of refraction of 2.42. If the angle of incidence is 67.1 degrees, what is the angle of refraction? All right, so we have N1 sine theta 1 is equal to N2 sine theta 2. Now you always, this is the incident side, and this is the refracted side. Okay, just read left to right. Okay, so we start out in air, and we end up in diamond. All right, so if we start out in air, N for air we know is 1.0. Right? The angle of incidence, the problem says, is 67.1 degrees. The N for diamond is 2.42, and we're trying to figure out theta 2. Okay, so the sine of theta 2, we're going to bring 2.42 underneath the left side. So it's 1.0 sine 67.1 degrees over 2.42. And that is 0.381. Now that's not the answer. Don't circle that. To get theta 2, we need to take the inverse sine. Make sure your calculator's in degrees. Inverse sine of 0.381. And you will get 22.4 degrees. So I know that answer makes sense because when light slows down, it causes the angle to get closer to the normal line. All right, so we start out a very wide angle, 67.1, and diamond is much more dense than air, so light bends a lot in diamond and gets much closer to the normal line. All right, and let's do 12.6. So 12.6 says a light ray travels through glass and then encounters air. If the angle of incidence is 34.6 degrees, what's the angle of refraction? Okay, so we have N1 sine theta 1 is equal to N2 sine theta 2. Now we're reading this problem left to right. We start out in glass, so that's N1. We the light beam travels then from glass into air. So this time air is into. Okay, so we have in one glass is 1.5 sine. The angle of incidence is 34.6. Okay, they can give you the angle of refraction and make you solve for the angle of incidence. That's fine, no problem. You're going to know 3 of these 4 unknowns. Air is 1.0. Into for air, the index of refraction, index of refraction for air is 1. You got to memorize that. And then sine theta 2. We want to try to find theta 2 again. So sine of theta 2 would be 1.5 sine 34.6. Make sure your calculator's in degrees. If you're in pre-cal right now, you might be putting your calculator in radians. Divided by 1. And that is going to be 58.4 degrees. Okay, that number makes sense to me because we're going from something slow to something fast. When that happens, the light bends further away from the normal line. So it started pretty close, 34.6 bent further away to 58.4. So the homework that goes along with this lecture, all right, is review questions. All right, page 421. All right, so review questions, page 421. You can do 4 through 8. All right, excuse me, I have to look at them real quick. Practice problems, page 422. All right, go ahead and do 4. You can skip number 5, a rare skip for me, 4, 6, and 7. All right, so that does it for Chapter 12, Lecture 2, and I will talk to you next time.